Every time you ask an AI chatbot a question, you are pulling from a physical reservoir of resources. Behind the interface, processing those prompts requires a constant flow of electricity and millions of liters of fresh water just for cooling the hardware. This chart shows the projected global energy consumption of AI data centers by 2027 compared to entire nations. The power required to keep these servers running is expected to surpass the total electricity usage of countries like Sweden or the Netherlands. Tech giants have largely solved the problem of acquiring enough advanced microchips to train their models. Their primary constraint now is finding enough electricity on local grids to actually plug those chips in. The battle for AI supremacy has moved from software engineering to heavy industry. Securing raw, massive baseline power is now the central requirement for the internet's expansion. Communities in the United States and Europe are pushing back against the water and energy drains these facilities cause. In cities like Berlin and Indianapolis, public resistance has forced tech companies to abandon planned data center projects. In response, the industry is looking toward the global south. Tech giants are focusing on India, drawn by the government's massive infrastructure rollouts and a regulatory environment that favors rapid development. India is moving to exploit this migration. By supplying the necessary physical space and energy, the country is positioning itself as the raw industrial engine room of the global AI era. The Adani Group is leading this shift in India. In early 2026, the conglomerate announced a $100 billion investment commitment to build out the physical infrastructure required for artificial intelligence. Historically, the business model involved simply leasing warehouse space to stack servers. Adani's new strategic model overhauls that approach. They are developing integrated green compute. This is a vertical monopoly where a single corporation owns the land, the data servers, the transmission lines, and the renewable energy plants required to keep the system online. In a market where power is the primary constraint, owning the generating capacity provides a level of certainty that simple real estate developers cannot match. This graph illustrates the core problem with renewables. The flat horizontal line represents the 24/7 power that AI demands. The erratic line is solar and wind generation. When renewable generation drops, it creates power deficits where data centers must draw from fossil fuel heavy grids. To solve this, Adani Atomic Energy is targeting 10 gigawatts of nuclear power capacity by 2035. Unlike solar, nuclear provides a steady flow of low carbon electricity that runs day and night. Pairing AI with nuclear generation is an attempt to satisfy non-stop digital demand without triggering a corresponding spike in coal emissions. The first major test of this model is taking shape in Visakhapatnam. Google and Adani are developing a $15 billion 1 gigawatt AI data center campus along the Andhra Pradesh coast. For Google, anchoring their infrastructure here provides the foundation to bring high performance computing resources directly to the Indian market. This expansion is triggering an intense domestic reaction. Reliance Industries has responded with its own $110 billion plan to build out AI and renewable infrastructure. Visakhapatnam represents the first tangible battlefield in a domestic arms race where conglomerates are spending hundreds of billions to secure control of the digital grid. While the project is marketed as green growth, local advocacy groups, including the Human Rights Forum, are petitioning the state to halt construction. They argue the approval process has bypassed substantive evaluations of local environmental impact. Visakhapatnam is already a water stressed region. Operating a 1 gigawatt facility in this climate requires billions of liters of water for cooling, which critics warn will lower the groundwater table and risk contamination from chemical runoff. This puts the 100% renewable claims under scrutiny. Without massive, uninterrupted clean energy storage, the state's grid will be forced to rely on fossil fuel backup to keep these heat intensive centers running during peak demand. The physical requirements of the Vizag project illustrate the strain of the digital cloud. It places a massive direct burden onto the natural resources of local communities. Data centers are highly automated, machine driven facilities. Once operational, they create only a few hundred permanent, highly specialized roles, leaving local employment limited to temporary construction and low skill maintenance work. There are also concerns over digital sovereignty. Outsourcing critical state data infrastructure to a multinational corporation places public systems within the private network of an entity driven by profit rather than public interest. This infrastructure also connects local resources to global conflicts. Tech companies like Google have faced intense international backlash for providing the AI and cloud tools used in military surveillance and logistical operations. A single project in Andhra Pradesh effectively ties local Indian water and power to the machinery of global corporate and military networks. Building the physical backbone of the global digital economy requires India to balance immense capital investment against the finite supply of its own land, water, and power. We are watching the intangible promise of artificial intelligence compete with the harsh physical reality of resource depletion. If the expansion of our digital future requires the exhaustion of our most basic natural resources, we have to ask who this progress is actually serving.